Okay, so up until this point, we've only talked about rectangular coordinates. And when I say rectangular coordinates, I mean an XY plane. So for rectangular coordinate system, we've got an origin, we've got an x-axis and a y-axis. And we would call these a rectangular coordinate system. And given any point P in this rectangular coordinate system, it's determined by x and y, where we understand that x is the distance we had to take on the x-axis, and y is the distance we had to take on the y-axis to get there. Now, when we talk about polar coordinates, it's a little bit different. We start with a pole, which we still consider the origin. We'll call it a pole. And then we extend from this pole a horizontal line, usually to the right, and we call this the polar axis. And so given any point in a polar coordinate system, we can write it in terms of r and theta. So what are they? Well, theta is going to be the angle that's created when we take the polar axis and we rotate it. So we rotate this initial side of the angle, and then we end up with a terminal side where if we extend that, if necessary, it's going to go through our point P. So this angle created here is theta, and then the directed distance from the pole to the point P we call r. And so in a polar coordinate system, everything is determined by an angle. It tells us where to go, and then we have this directed distance r that tells us how to get to our point. Now there's a couple things that can happen, and we'll plot some points in just a second, but I just want to make a couple notes. The first note is that the point is that r can be negative. So in the first picture that I've drawn you, or the first diagram, I guess, we are assuming that r is positive and theta is positive, but that doesn't have to be the case. So if r is negative, what is that going to look like? Well, let's see. We are drawing a polar coordinate system, so we start with our pole, polar axis, and then let's draw the point P equals r theta again. So we're right here, and this means that we go over theta, and then we draw this directed distance from the origin to our point and call this r. Well, if r was negative, what would we do? We would actually go the opposite direction. So we would extend the terminal side of this angle theta and go the opposite direction with the same distance r. And so this would constitute negative r, and so we would call this point here P equals negative r theta. Now, the angle theta can also be negative. So theta can be negative. And so just draw a small diagram of what happens if that's the case. So once again, if we're starting with our pole, to draw theta negative, let's see, so if we have P r theta right here, then if theta is negative, what that means is that instead of rotating counterclockwise to get to theta, we're rotating clockwise now. So we're going to go clockwise, and this is going to be negative theta. And then we still have our distance r. So r is a little bit shorter in this diagram. And then we get to the point P equals r negative theta. So if you look, every time I'm plotting a point, I use the angle first and then I use the distance r. Now in this same vein, in this diagram, if I wanted to plot P negative r negative theta, I would still go down negative theta, and then I would draw, I would extend the terminal side of this angle in the opposite direction of length r. And so my point here, P equals negative r negative theta. So this is all kind of abstract. Let's see what this looks like in some real examples. Here, this is what a Cartesian coordinate system looks like. This is kind of a polar coordinate system, excuse me. So we want to plot the points for pi over 3, and we're going to call that point A. So just a real quick of what's happening here, this is kind of like this is our polar axis. And each distance here, this will be 1, 2, 3, etc., is going to extend around. So at any point in the dotted line that I'm drawing, r is going to be equal to 1. Similar, on any point of this dotted line that I'm drawing, r is going to be equal to 2. Okay, and so let's see how to use this. We want to draw the point A equals 4 pi over 3. So the first thing we do is we rotate this polar axis, or the terminal side of our angle, initial side of our angle, over pi over 3 degrees. So it's going to go like this. And then we draw a line. So this is our angle theta, equals pi over 3. But then where's our point? Well, we're going to r equals 4. So we've got 1, 2, 3, 4. And so you can kind of follow that. It's going to be right here. So this is the point A equals 4 pi over 3. All right, so the next point we want to plot is 2 negative pi over 6. So this is going to be a situation where the angle is negative. So everything's in 15 degrees. So negative pi over 6 is going to be right here. This is going to be negative 30 degrees. And so what we want to do is plot. So we want to rotate our axis to 30 degrees. And then where do we draw our point? Well, we have r equals 2, so that's going to be right here. So this is the point B equals 2 negative pi over 6. So we had to rotate clockwise this time because the angle was negative. Here we have r is negative, theta is positive. So let's see, we have start off with our initial side. And then we rotate pi over 4 degrees. So that's going to be 45 degrees. And then if we were having r positive, then 1, 2, 3, 4, 5. This would be 5 pi over 4. But we want negative 5 pi over 4. So we're going to have to go out 2, 3, 4, 5 and extend the terminal side of theta the opposite direction, and we're going to get C equals negative 5 pi over 4. Lastly, let's see, we've got D equals negative 3 negative pi over 2. So both theta and r are negative. So we're going to start with theta always. So we've got our initial side of our angle. We're going to rotate it clockwise pi over 2 degrees. And then let's see, if r was positive, then we would have this point right here is going to be 3 negative pi over 2. But we have that r is negative, so we're going to go in the opposite direction of the terminal side of this angle and stop right here. So this is going to be the point D equals negative 3 negative pi over 2.